All right, hello. Let's look at section 3.5. This is about dividing polynomials. And we're going to focus on a strategy that is known as synthetic division. And if this seems super hard and a little bonkers to you, trust me, it sure beats the alternative. If anyone wants to read the textbook in full, you can experience the joy of polynomial long division, which if you have any memories of old school long division with straight up numbers and it makes you cringe and wither in fear, just know that polynomial long division is quite challenging, but we're going to cut to the chase and just focus on the sort of quick and easy method that we're going to use a whole bunch of times throughout the rest of the chapter. So what is synthetic division and how does it work? Well, here's the first thing that we're going to do. So we're doing 5x squared minus 3x minus 36. And we're taking that and we are dividing that by x minus 3. So that's kind of a more standard way to write the division problem. But that doesn't necessarily answer the question of like, how are we going to do this? Well, here's how we're going to do this. We're going to start with this thing right here. And again, we've seen this before where you have like the factor, which is x minus 3. And then you have the 0, which is just, in this case, it would be the number 3. Because like we saw previously, if you want to go from the factor to the 0 or the x-intercept, which would be the point 3 comma 0, these are all very similar things to each other, but there's sort of slight variations. But anyway, the thing I want to emphasize is just the fact that if you have x minus 3 as the factor in parentheses, the thing you're dividing by, that means the 0 is a 3. So the number that we care about is a 3. So here's what we're going to do. And I'm missing the square right here. But anyway, so here's what we're going to do. We're going to do a 3, and then we do sort of an inverted long division sign, which looks something kind of like that. Then here's what we're going to do. Basically, the idea of synthetic division is that we're just sort of ignoring or removing the x's and mainly concentrating on what the numbers are, and then we can put the x's back in when we're done. But we're trying to sort of simplify and streamline the process so that we don't have lots of variables of x's running around. Let's just focus on the numbers. The way to do that, we're basically going to make a column for x squared, followed by x, and then finally the number term. So the number with x squared is a 5. The number with x would be -3. You take the negative sign with it. And then just the straight up number by itself, that will be -36. Okay, so here's basically how synthetic division works. You're basically going to do 2 steps over and over again until you run out of numbers. And here's how synthetic division works. Here's the big idea. What you're going to do is you're going to add down, and then you're going to multiply diagonally. And if that isn't quite clear yet, what I mean by that, bear with me. I think this will make a lot more sense once I actually start showing it to you, but this is kind of how it works. So you're going to add down. Now, the first thing you might notice is that like, well, there's nothing to add to it. Well, that's fine. Just drop it straight on down here. There's a 5 right there. So then what we're going to do is we're going to multiply diagonally. So we're going to go up here. What do we multiply by? We're going to multiply by 3. So we're going to do times 3. Because this number right here, this is going to be our multiplier. Every time we do this, we are going to multiply by 3. Let me try to write that maybe a little more clearly. So we're going to do times 3. Okay, so what is 5 times 3? That is the number 15. Then, like before, you're going to add, well, we didn't really add last time, but now we're actually going to add going down. -3 plus 15, that is the number 12. Okay, then we're going to do the same thing that we did earlier. We're going to take this, we're going to take it, we're going to multiply by our multiplier, which is a 3 every single time. That's the significance of the number out here. So you do 12 times 3, and that gives you 36. And then you add one last time, -36 plus 36 is the number 0. So there you go. This, by the way, the final number, that is the remainder. And later in the chapter, we'll focus more attention on the significance of a remainder of 0. But suffice to say, when you divide and you have a remainder of 0, that is super major awesomeness happy times right there, because that means like everything is going your way and like all is right with the world. We love to see ourselves remainders of 0. That means nothing's left over. Everything was used perfectly and exactly. All right, well, now we need to come up with the answer. So now that we're ready for the answer, let me just write this again with a little less commentary. We had 5, -3, -36. This was 15, 36. This is 5, 12, and 0. So if we go back to the beginning, what I was saying was we took the x's out, set them aside, focused on only the numbers. Now that we're done with the numbers, we're going to put the x's back in. So the question is, how do you do that? Well, originally you had x squared, x, and number. And so everyone is going to, we're going to drop the powers by 1. So essentially what that means is that x squared goes down to x, x goes down to number, number goes down to remainder. And so then what this means, if you put all of this together, is that you will get 5x plus 12, and that is the answer. So the answer, if you do 5x plus 12, that will be the answer. Now you can check, in the interest of time, I'm not going to do it, but what you can do, if you are so inclined, is you can check, and if you do 5x plus 12, the answer that we got, and if you multiply it by the factor we started with, which was x minus 3, if you use FOIL and multiply those things out, what you should get is the thing we started with, 5x squared minus 3x minus 36. In the interest of time, I'm not going to take the trouble to do that, but just something to be aware. If you take the answer you get and multiply it by what we divided by, you should end up back where you started. All right. Let's do this same kind of thing again. So the factor that we have, we're dividing by x plus 2. So the factor is x plus 2. And so that's another way of saying that the 0 is -2. And then that also means that the x-intercept on the graph is -2, 0. Those are 3 very similar and interrelated ideas that are going to be very important throughout the whole of this chapter. But so what we care about for synthetic division is this right here. We care about the value of the 0, which in this case is -2. So we've got -2 right here. And so what do we have? We've got x to the 3rd. X to the 3rd, x squared, x, and then number. So what are the different values? You have a 4, a 10, a -6, and a negative 20. All right, and the thing to remember, you add going down and you multiply diagonally. And again, the negative 2 that's out front, that is going to be our multiplier. We're going to multiply by that every single time. So 4 just comes straight on down. And we multiply this by negative 2. And when we do, 4 times negative 2 is negative 8. 10 plus negative 8, also known as 10 minus 8, is the number 2. 2 times negative 2. 2 times negative 2 is going to be the number negative 4. Negative 6 plus negative 4 is the number negative 10. Multiply that by negative 2. Negative 10 times negative 2 is positive 20. Negative 20 plus 20 is 0. All the powers are going to drop one step. So we're going to drop the powers by 1. So x to the third goes down to x squared. X squared goes down to x. X goes down to number. Number goes down to remainder. And the remainder is 0 again, which is nice. We don't have anything left over that we have to worry about. So what we're going to do is we're going to put the x's back into the problem. And if we do, what we will end up with is this: 4x squared plus 2x minus 10. And then that is the solution we get by doing synthetic division with that problem. And again, if you took that answer, multiplied it by x plus 2, and did a whole lot of distributive property and combined some like terms, you would end up back with what you started with. And again, that would just be to like check your work. And like I said, in the interest of time, we're not going to take the trouble to do that. But just be aware that that would be a thing. That's what happens. Here's another one. Here's x minus 1. That is the factor. And so then that corresponds to the 0, which would just be 1. Now, let's see. So we're going to put a 1 out here. And I want to point something out to you, which is to notice here's x squared. There is a number. Now, these are supposed to be in order: x to the 4th, x to the 3rd, x squared, x, and then the number, the constant. So the x to the 4th is going to be negative 9, x to the 3rd is 10, x squared is 7. There's nothing for x. Now we do need to have a placeholder because we can't just up and jump over and skip an entire power of x. That's the one catch with this strategy. But that's easily solved. Since there's no x, that would just mean that this is a 0 because there's nothing there. And then when it comes to the number all the way back in the back is negative 6. So when you're doing these kind of problems, it's important to really read the fine print and just check and make sure that all of your powers of x are present and correct. If anything is missing, then you need to put in a 0 as a placeholder for the missing power of x. So a wise man once said, check yourself before you wreck yourself. I think that was Socrates. It might have been Ice Cube. I mix up my Greek philosophers and my early 90s rappers sometime, but it's still good advice. Check yourself before you wreck yourself. So just make sure nothing's missing. That's what I'm saying. Okay, anyway, so yet again, add down and then multiply diagonally. Okay, so the first number just drops straight down, -9. You're going to multiply that by 1, which means it's just going to be negative 9 again. 10 minus 9 is 1. Multiply that by 1, which is still 1. 7 plus 1 is 8. You multiply that by 1, which is still 8. And then let's see here. 0 plus 8 is going to give you 8. You're going to multiply by 1, which is 8. And then -6 plus 8 is going to give you the number 2. So then if we put the x's back in, this is x to the third, x squared, x number, and then remainder. Now this will be kind of a new one because we haven't seen what happens when you get a remainder. So that's what we're going to look at here. So a lot of the beginning of this is very similar to like what we've done already. So we're going to have -9x to the third plus x squared. I mean, you could put a 1 there, but usually you don't take the trouble to write it. So that's just x squared. This will be plus 8x. This will be plus 8. And then here's what you do with the remainder. Because this is a 2, we're going to call this plus 2 divided by x minus 1. And then that would be your answer. So with a remainder, that is not 0, the final term is the remainder over the factor. And again, the factor is just the thing that we were dividing by, x minus 1. The remainder is a 2. So then what that translates into is you have 2 over x minus 1. That's what you put on the end if you have a remainder that is not 0. So that is that one right there. And again, the other big thing to note about this problem is this is how to handle a situation where one of your powers of x is missing. Because wherever you start, whatever power, like 5th power, 4th power, 3rd power, whatever, whichever power you're starting with, you need to start at that number and have all the values going down. So you have, go back. So you have 4, 3, 2, this would be 1, and then this would be like 0 because there's no x's. So all the powers of x need to be accounted for. All right, we've got one last example. And this is pretty similar to what we've been doing already. There's not a whole lot new at this point with this last one. So the factor is x plus 7. That would mean that the 0 is -7. Just take the value and switch its sign. So the multiplier that we're going to use is going to be -7. You've got x to the 4th is the highest power. You've got x to the 3rd, x squared, x, and then number. Like before, notice that there's a gap here. You've got x to the 3rd and you've got an x, but you need to have a spot for the x squared, because that's the one catch about this process is it's not going to work correctly if any of the terms are missing. That's sort of the drawback of like taking out all the x's. Well, if something's missing, you need to have a 0 in there as a placeholder. So what would this be? This would be a 3. That would be an 18. There would be a 0 because there's a gap right there. For the x, there's a -3. And for the number, it is just a positive 40. All right, so you add down, multiply diagonally. Okay, so the 3 just drops on down. All right, 3 times -7 is -21. -18 plus I'm sorry, 18 plus -21 would be -3. -3 times -7 is +21. 0 plus 21 is 21. Let's see, 21 times -7. Let's see what that is. I have the impression this one's not going to give us a remainder of 0, but that's okay. That is, let's see, -147 is what that is. -3 plus -147 is -150. And then we're gonna multiply that by, we're gonna multiply that by -7, which will be +1050. It's gonna be a pretty big, this is gonna be a pretty big remainder right here. 40 plus 1050 is 1090. All right. So there you go. That's a mighty large number there, but it is what it is. You get what you get. All right, so every power is going to drop down 1. This is x to the 3rd, x squared, x number, and then remainder. So if we're going to write this for our final answer, we're going to have 3x to the 3rd minus 3x squared. And then we have, let's see here, plus 21x minus 150, and then plus 1090 over x plus 7. All right, and there you have it. That is the result that you get from dividing those polynomials. Okay, so that is the end of the section. So we'll stop there.